So hello, welcome to my talk about new assertions in Pester. Thanks to the sponsors. Without them, we wouldn't be able to be here. Also, without all of you, because without attendees, not much of a conference. So hi, I'm Jakub. I maintain Pester and also Profiler. That's what I do in evenings and when I have some free time. During my day, I work for Microsoft developing .NET testing tooling like VS Test, Testing Platform, and MS Test. I don't represent Microsoft here today, so all opinions are mine. And if you or your company is using my open source product or ours open source products, please consider sponsoring me or Pester so I can do stuff like this, make t-shirts, come to conferences, and so on. Another great news is that we have Frode here, the co-maintainer of Pester, with us. If you haven't met him in person, there's your chance. I'm pretty sure some of you already spoke with him on GitHub because he's been maintaining Pester and Pester docs. He created 200, now it's 200 plus PRs for Pester and Pester docs. He solved many, many issues and a lot of the discussions that are there. Maybe all of them. I'm not sure, but very close to it. So yeah, if we can give it up for Frode. Thank you. So, the new assertions. We now have Pester 6 in alpha. I think it's alpha free since today's morning, like 20 minutes after midnight. And there we have new syntax for the should assertions, which is should be without the space. So it's a standalone function that is exported from the Pester module. And it's a small change from the previous one. If you're now worried that we're breaking all your tests, that's not the case because the should-b, where the b is the parameter, is living forward, and I took care to not make any changes to how that works. We have totally different code for the formatting for the new should-be. We didn't touch any of the conditions or anything, so this continues working on, and we will be deprecating it somewhere in the future, but not just yet. So why? The reason is that every release of Pester needs new assert syntax so we can break DBA checks. So in version 1 and version 2, we had this extension syntax. Some people call it magic functions. Then in version 3, we had the should be without the dash. That got deprecated and removed. Then we had should be with the parameter in version 4 and version 5. And now in version 6, the new should be as a standalone function is coming. Without joking, the real reason is that the parameter sets that we're leveraging for the should function in v5 are limited, and they're represented as a number that only has 32 bits. And every time you have a parameter set, you set a flag. You set one of the numbers in that number to 1. And so it's a hard limit for us that we cannot pass. And we are now very close to the limit. Plus, we have the extensibility where you can add your own assertions. And so people are running into this limitation, unfortunately. It is possible, probably very easily, to lift it in PowerShell 7, but we would have to live with it in PowerShell 5.1. And so that's not a limitation that I know how to overcome. And so new syntax. Also, the current should function has a lot of problems with consistency. When you give it arrays, when you give it single items, it's very confusing how stuff works and it's not very well categorized. So I thought maybe we can do better. And when I was thinking about it a few years ago, I created this assert module, where I tried to discover stuff that works and doesn't work for assertions, and how to do stuff better, how we can overcome some of the problems that we have now, be more consistent, and so on. And every time I presented about it, people ask me, why is that coming to Pester? Because for some reason, it's too difficult to install the module side by side. I don't know why, but I agree with them. If it was inside of Pester directly, it would be better. And so that's what's happening now. I took this module, ported all the code into Pester, did ton of changes to make it the same experience you are used to in Pester. So the messages are the same kind of format, they have the same order, all the functions are called should, and so on. And with that, the assert module now became just maintenance only. There was also some problem that prevented it to work in PowerShell 7, so I fixed that, released a new version. Recently, there was also a contribution that added some tiny fixes, but apart from that, it's just maintenance only. There will be no more new features in this module. But in Pester 6, we have all of them ported, and we have new other assertions. So I split them into different categories so they can have specific rules on how to behave. And the big broad categories are value assertions, collection assertions, and then we have assertion for equivalency. And in the value assertions, we have generic assertions that accept any type of value, and type-specific that are specialized on a specific type of thing, like a Boolean or a string. Then we have collection assertions, we have generic, and combinators that help you combine with other assertions. So let's go through all of that. So value assertions will always accept a single value for the expected. So no collections, so we don't end up in the same confusing behavior that we have in the should be in version 5. And when you provide a single item array through pipeline, it will always handle it as a single value, because we cannot see through the pipeline what that kind of value is. And so it leads to a lot of confusing behaviors if you want to do the thing that's on line 2. On the other hand, if you provide the value through the parameters, we always take it literally as it is. So what exactly you provide, we take and compare. So we have this flexibility to either use the kind of Fluent syntax or to use the more specific parameter syntax. So the behavior, for example, of should be, which is a representative of our generic value assertions, is that we accept any type of data and we convert it to the type of expected, just as the PowerShell operator does it. That helped. So let's see that in action. I hope that's time for the demo. Yep. Code. This one. And we go back to 1. Is that big enough? I probably can go a little bigger. Let's see. So first we have the most basic example. We pipe 1 into should be and we expect 1. So this should pass. I should see no output because no exception was thrown. And when I do the same and I have an array, it has a single item and I pipe it in, it will also pass because we consider this a single value. If I take a value that's not equal to the expected, I will get an error as expected. And it tells me I expected an integer 1, but I got an integer 2. And so I'm trying to follow this kind of format in all the exception messages, where you can see the type and you can see the value, and then but it could be followed with the because string, or I think it might be here in the middle would be the because string if we had it, and then there would be but and again a type and the value. So this way you can know very specifically what you provided and what you got. When you get into things that are converting to one thing or another, you will see what was the exact value. Then we are in the situation where we are trying to provide an array onto the expected, and we said that's not allowed. So if I run this, I will get a long message that tells me, don't provide collections to the expected, use some of the specialized collection assertions, because then you can combine and you can compare the arrays more easily. So it looks a little scary, but it can be also improved, but it has all the information on what you need to do, so you don't accidentally end up in a bad situation. If we do it on the other way, if we provide an array to the actual side, then we will do simply a comparison, and 1 and 2 is not the same as 1, and so the assertion fails. And again, we see I expected integer 1, but got an object array that had those items. We can try and do the same with null, and see that we here have a type of null, even though that's probably not the exact type it has. But it helps me to not have a special assertion message for every single place where null could be accepted. And so after you accept it as a thing, it's not confusing anymore, and it works in all the other places as well. Here I want to show that if I provide it using the parameter syntax, as we had in the example here, if we use the same things in the parameter syntax, we take them literally as you provide them. So this will still pass because we compare 1 to 1, but this will no longer pass because we are now comparing an array with one item that's 1 to number 1. And so similarly as before, we see we expect an integer, but we got an array of 1. So if you end up in a situation where you really need to know if there is an array or not, then you need to use this kind of syntax instead of the pipeline, because the pipeline will just either expand it or wrap it. And then in the last things, if I'm trying to be a little cheeky with the output, with the input to the assertion, for example, I give a string that has the null inside of it. That can be sometimes a little confusing. So here I can see this is a type null and a null, but I got a string that was the text null. So that's why the types are also there, because sometimes it could be pretty difficult with the previous assertions to see what exactly you are getting. And similarly with an empty string. Here I'm thinking about replacing this empty with just the single quotes. I think it will play nicely, but I will try it and see it. And this is also an opportunity for you to go to GitHub repo and tell me, this is a bad idea, I don't like this output, I would like this output to be this way. Why are we missing those assertions? Because now we can have limitless amount of assertions almost. And if you have like a place or a use case that you think would be nice to have as a separate assertion, then tell us. Like Frode was telling me, in Entra, in AD, you have a lot of places where you need to do like bit masks, and it could be nice to have shoulds that are specific to that could do the things for you. So you don't have to like put the ands and bends and together to work. So I think this will be nice to have like a boom of additional assertions. Okay, so that's what we saw. Generic value assertions take whatever value from one side, they convert it to the expected side and compare it. So if we have a true and compare it to true, it will be true. If we have 1, it will be converted into true. If we have string false, it's still a non-empty string. It will be converted to Boolean true, and this assertion will pass. This is the anatomy of assertion failures. So we have a type, we have an array. Even though in one of the messages you saw that if we have an array and it has just single item, it's not wrapped into this. That's a bug that I tried to solve. It broke everything. So in the future, it will be there, but not right now. And then we have this special null type that signifies a null thing. Then we can move on to type-specific value assertions. Those are value assertions, so they still take just a single value, but they are specialized to one type. They don't cast the input to the expected type, so you can be very strict about what you expect. And they provide more options that are specific to the type of the data that you are trying to assert on. So we clear this up. Here I have a true and I pipe it into should be true. And it passes because those two things are equal. But when I take 1 and I pipe it into should be true, it fails because this is not a Boolean, it's an integer, and we don't convert the values. So it tells me, no. You expected exactly true, but you gave me 1, even though it's convertible. I don't care. This is not the right value. Same for the false. Also same for the null. And we would see the same when we pipe null into should be false. It should still fail. So this way you can write assertions that are very, very specific to the type. If you don't like that and you like the behavior that should be has, we have a new assertion that's called should be truthy. It converts it and okay, I see some smiles, but this is a nice word. And yeah, okay. I don't know why I scrolled up. So we pipe it in and nothing happens. We don't get any error. So the assertion passed. And we can do also the same with should be true, which is a generic assertion. So it converts and it will accept the value and will work. So the should be true is probably not very useful to everyone, but it's good to have it there because we have a lot of complaints about this specific thing not working. So you always have options how to do it. And I always try to make the should be kind of more generic, more open, more multi-purpose, but not to the point where it's super confusing on what it's actually doing. Yes.
When will should be truthy fill?
I'm sorry, when should
be truthy fill?
When it will fail? For example, if you give it 0 or?
Yeah, the line 12.
This one?
Yeah.
This one will fail when you give it a non-truthy value. So if it's 0, if it's null, if it's an empty string, anything that would convert to a Boolean false, it will fail. If you give it string false, it will pass because that's a non-empty string. And this is...
From the time, if you do string false equals die false, you get...
Is this a bet? No?
It has to be an empty string for string.
Yeah, this is confusing, but it works like this. Unfortunately, no. I would like it as well, but you will see it. We can do it in those new assertions, so... Oh, yeah, so should be truthy would fail if we do 0. Should be truthy. That fails because it cannot convert. Yes, please.
Certainly, if you make a string with 0, that would be true.
Yes, if this would if I would change this into a string, it would be true because it's not an empty string. So only an empty string will convert to false or null or 0 or the false itself, right? Any more questions to this? Okay, cool. So now we have another specialized assertion, and this one is specialized to string. There can be a lot of cool stuff that I would like to do with it, but so far we are here. And so we can compare should be string, non-case sensitively by default, similar to how the normal operators work. And so both of those assertions pass, ABC, even the capital ABC. But then maybe I have a preference to use case sensitive, so I just go here and I say case sensitive instead of should be exactly, because no one knows what that means. And so that's more obvious. But maybe we also want to ignore all the white space in the string, like we're comparing code that's output from something to other code that we expect, or we are generating a report and we don't really care about, well, for a report, we probably care about how it looks like on the screen, but for the code, as long as it runs, and no one reads it because we generated it, we don't care about white space that much if it compiles or if it runs. And so we can use ignore white space to ignore all the white space in the string. So this will pass like a handy shortcut so you don't have to write it yourself. We can also just trim the white space at the start or the end. Maybe you're comparing lines and you don't want to handle the white space on different systems and so on, have this long environment, new line. So this would be a useful place where to use it. This one fails because we expect ABC without any spaces in the middle, but what we get is ABC with spaces in the middle. And I'm also planning to improve those messages. So either they compare the text as a div, if we can do that. There are some cool libraries to do this. Or at least like point out where the difference is, maybe show the string before and after. It's all subject to change, but the functionality is there. So you can already go and check the strings like this. This is also a non-generic assertion. So if you wanted to compare to string, you have to cast it to the string yourself. We can, in theory, add an option to not do this. So you can allow the casting. But the reason to do this was that sometimes you pipe in an object and it translates into a string and you are expecting a string. But in reality, you want to have the object on what you are providing. So it leads to confusing errors when the assertion passes. Yes, please, Leo.
Would a character array be referred to a string like this?
I don't think so. We can try it if a character array would be a string. So is this what you imagined? No. You mean more like this, right? Yeah, no. Maybe I'm just not doing it right.
Direct space passage.
No syntax.
Huh? Oh. Early alpha. Still no. It casts it into object array, so probably this wouldn't work, no.
It's because it pipes each element individually when you do it that way.
Yeah, and I think that's what we get because we collect the input from the automatic variable, and this is what we get, so this is what we use. Make a pull request, please, and fix this. And in similar category to the should be string, we have should be like string. They will be should match string, so they will leverage the built-in operators for regex. This leverages the one for the wildcards. So we can compare it like this. Maybe we can invent another one if there is a need to do something more advanced, but those should probably cover most of the use cases. So here I'm comparing to something that should end with BC, and this one passes, but this one doesn't pass because this string doesn't end with BC. Probably we can also add options to like ignore white space, trim white space, and so on. If there's a need. It's open to pull requests, as I said. Okay. And I should hurry up. I have too much content. So just to recap, type-specific value assertions take the specific type. If you don't provide it, it will fail right out because the type is needed, and then they specialize on a given value, like a Boolean or a string. So they can provide options that are just specific to that. Why did I just do that? Then we have collection assertions. Those assertions focus on collections, so you can check if something is the same collection as before. If it contains a collection, there will be options to like check if it's in order, if it's not in order, and so on. And so collection assertions will take a collection to the actual. And this one here will be converted into a collection as well, because that's what the pipeline does, and we don't special case it. But if you provide the values using the parameters like here, you are providing just a naked one, and that's not an array, so the assertion will blow up because it's an integer. Good. So collection assertions, here we can see how that works. We have both the same collection on the actual and the expected side, and this assertion passes. When I'm providing one and it's not wrapped into a collection, it still passes because we translate it into that. So that's the difference between the value and the collection assertions. And then when we provide a collections that is different to the actual side than what we expect, we get an error message that tells us, I expected this collection to be present in the other collection in any order, because that's the settings that I have right now. But it's missing here on index 1 and index 2. So it's 4 and 5 on index 1 and 2. And we have some extra values in the actual 1 and 2 on index 0 and index 1. Here, it's probably very easy to see what's happening in those collections, but if you have some objects that actually don't translate very well into text, then the indexes become more handy for you to know which exact object, so then you can like start debugging or do something like that instead of just seeing, I expected an object and I got an object. Wouldn't be very helpful. Okay, so that was actually this slide. So we accept multiple types of input data. They act similarly to the generic value assertions. They convert the actual to the expected type, and they act similarly to PowerShell operators. And then we have a second category, which I call combinator, which is probably not the right technical term, but I like it because it kind of makes sense. And so you can take those assertions and combine them with your predicate. They take a script block, like a where object, or you can also combine them with other should assertions. So you end up in a place where you'd say should, any, should be, and so on. And this way, it's making the value assertions more powerful because you can run them on a collection. So here we have an example of that. We go in here, we provide a collection to the actual side, and to the expected side, we provide a script block that outputs a Boolean, or it doesn't output anything. If you output a false from this script block, it will fail the assertion. If you don't output anything, it will not fail the assertion. This is because the should be, in this case, it doesn't output anything. So we really have to check just specifically for false or for an error. So if you output a string, it will pass the assertion. So unless it's false, it will pass. So here I run, and I expect all the values in the collection to be greater than 0, and they all are, so I get a pass. If I expect all the items in the collection to be less than 2, I have two items that are not that, so 2 and 3 are not less than 2. And I get an error, and it tells me, I expected all the items in this collection to pass this filter, but 2 of them, this one and this one, did not pass the filter. And I know what happened. But I can also combine this with a B assertion and run it, and then I get even better error message, which tells me, I expected this to pass this, 2 of those items didn't pass, and those are the reasons why they did not pass. And this way, if we combine the assertions together with the specialized string assertions and so on, I think this can be quite powerful to express the stuff that you want. Why did I put the water so far? Okay, where were we? So that was this example for should all. So in this case, we expect all the values in the collection to pass the predicate, but we can have a different situation where we just expect at least one of the items to pass the predicate. And that's represented by the should any assertion. So in here, we have 1 and 2 and 3, and we say at least one of those items should be less than 2. And we have such item, it's 1. But then if we check on the same collection and we say at least 1 should be greater than 4, we have no such item. And so the assertion again fails. And we get the reasons for every single item why it didn't pass the filter. Any questions so far? No. Good. Yes.
You should be able, does it take a single script block or just an array of script blocks?
It takes a single script block. I didn't even think about taking an array. So what's your use case? Applying it on each item, right?
Anyone in this condition, like you might assign the condition to a variable and then reuse that condition in multiple variables.
Okay. File an issue, please.
You could do it in one script block, but you have to write all the necessary combination logic yourself. If you migrate all that into the command, and then it'd be simpler. You would have to write a lot of commands and all this and stuff.
So to repeat the question, it was if it takes a single script block or multiple script blocks, because then we can reuse them in a better way, in a more built-in way. So Bruce, please create an issue, and maybe it will be there next year. Yes, please. All of this can be replaced with for each loops. A whole Pester can be replaced with that. It's just a for each loop and some try catches, and we're done. I agree. Please.
So the content of the script block should eventually give a true or false. So I can also use logic operators in that, like and more, to have multiple statements in the script block.
You can have absolutely everything there as long as it outputs false when you have the result. Actually, it's if it outputs false, that's yes, false. I will not complicate it any further. So maybe it will change the logic in the future as well. But yes, if it outputs false or if it throws an exception, it will fail the script block. Any other case should be a pass.
Is it false or falsy?
No, it's false. It's
just curious because it sounds it's similar to where object, but that works all like falsy
okay.
option.
Okay, I haven't thought about that, so another issue in the making. Or a pull request. And the question was if it's false or falsy. So yes, the result needs to be false right now, but maybe not in the future. Where were we? So yeah, we saw all the demos here. That's good. So the collection combinator assertion allow you to do this kind of stuff when there will be more assertions, and there might be more of the combinators as well, more options to them, and so on. So this is the start. We went through this, so that's perfect. And then we have the last category, and that's equivalency. And so this was like the highlight of the assert module that I had, because this allows you to compare deeper object structures for equivalency or equality. And so let's look into what that means. So in PowerShell, we have this EQ operator, which is equality. And if I have two objects like this, they are compared by reference. So even though to our human eyes, they look the same, they have the same data, the same structure, for PowerShell, they are different because they are not the same thing. And so when I compare them, I get false. And if I wanted to have an operator that's similar, but it would be equivalency, I would have to navigate into the object, compare the values in every single place, and make sure that the structure is the same, the names are the same, the values are the same, and so on. Unfortunately, that doesn't exist, but we can implement it ourselves as a function. And so here in my first example, I have this kind of simple object where I have my name, age, and some languages. I will define that as expected. And then I have a similar object, but in the languages, the order is switched. And I define that as actual. I run it through the should be equivalent function, and it passes because it went and it compared the whole object. It doesn't care about the order and so on, and the values are just the same. Now, if I go into my expected object and I say, oh God, go away. I add TypeScript to my languages and drinks coffee. And I actually don't have the TypeScript, but I have a small keyboard. Now you know all my hobbies. And I run should be expected. I get a big red message. And it tells me I expected those two objects to be equivalent, but they are not. So this is how they look like. It orders the object properties alphabetically, so you have easier time comparing them visually as well. It orders all the items, I think. Oh, no, it doesn't. Okay, just the properties. And then it tells you, I expected the collection in this dot languages to have this with length 3, but it actually had this. We have additional properties that one of the objects doesn't have. We have this property that the other object doesn't have. And so it gives you an overview of everything, of what happened. And if you notice this little dot, it uses it everywhere for the navigation. So if the difference was deeper, you would get the whole path to the property that was different. You can also then take this path and use it for exclusions, or for inclusions, it is quite flexible. But doing this is kind of manual work, and it's annoying when you have to compare two big objects and then just exclude everything manually. So my favorite mode is when I have this defined. I define this as well. You can see this object is more complicated, but I don't need all of that info. For example, I received it from an API, converted it from JSON, and I want to know, like, is this subset of things I care about in that other object? So I use my should be equivalent, and I say exclude the paths that are not unexpected. So it will only collect everything that's unexpected, look at the actual, and compare the two objects. And for me, that passes because all of those things are there. This object is contained in this other object. But if I change this to PowerShell 2 and redefine it again, we will end up with an error that the objects are not the same.
It's doing like the generic type checking, right? So it's going to cast what's it expected for that property to belong in actual to expected.
In most places, yes. It also takes the false string and casts it to false instead of true.
Okay.
And small things like that.
Yeah.
So it tries to do this. There are some options to disable some of the things. You can also say that you don't want the equivalency comparator for the equality, but you want equality. No, for the comparison, you want to use either equivalency comparison or equality comparison. So it behaves the same as PowerShell does, and then you get your false string going into true rather than the other way around. Yes, please.
The attribute name checking case sensitive.
If it is case sensitive, I don't think in the equivalency it is case sensitive, no. But in the equality, probably no as well. It probably uses the EQ operator for something.
So PowerShell properties have to be case sensitive, I'm pretty sure. Like they can't have the same property with different case names.
It's in .NET, but the .NET guidelines say you should not have multi-case properties. It should always be a single element regardless of the lowercase.
Yes. Okay. So the comments were. No. I'm just trying to repeat it for the recordings because we're not passing mics around. The comments were that in C# you shouldn't be using properties that have different casing because it's not a good practice. And then in PowerShell you probably cannot even define properties with different casing because they will end up being the same. In this case, I think we are comparing them case insensitively because this mostly works on PowerShell objects. But I might be wrong. So if you have a special use case where you really need to do this, again, file a PR or an issue.
And does this work on dictionaries or just?
This should work on anything. Should, in theory. But there are a lot of special cases like data tables and so on that we can capture. There is an internal table that converts some of the objects into collection of properties that represent them, like process, that has data on itself that you probably wouldn't be able to capture to be the same. So we compare like an ID and a name of process instead of start time. Well, this doesn't make sense. If it has the same ID, probably you would have to try very hard and restart until you get the same ID. But stuff like that, if you run into an edge case, we can somehow maybe capture it in the internal state so it works. Data tables are recursive and stuff like that. So even right now, there is a bug with some type being recursive. There's a question, and you had another one, right?
Yeah, I was wondering if you could use script blocks as the value in the comparison. So you basically write a predicate. So property foo, this script block gets run to return true or false, and handling the match that way. So if you want it to be case specific property, you can do it through a script.
Right. Yeah. So the comment was if we took a script block for a path, we could provide a script block that would, on that path within the object, do the comparison yourself. I think that would be a good extension. That would give people a lot of flexibility. Is this becoming Braid? What was your question?
Does it also compare the type of the main object, or if I get something from a command block in a specific type of object, and I make a PS custom object just to have only some values I want to compare with the last option? Will this work, or do I need to make sure that it's the same type of object?
I think it should work. It works largely on like a graph of those paths that we had there that are being compared. So as long as the path has the same value, it considers it to be the same. I'm not 100% sure in the equality kind of way of comparing stuff if we also compare the type, but it can be changed and extended or making more relaxed as well. Did I repeat the question? No. So the question was if it compares the type of the object as well. So can I just construct a PS custom object that looks like the other object that doesn't have that type and compare them? You should be able to, because that was the original idea behind this whole thing, I think. Do we have more demos? No. This was the last one for the equivalency. There's still 2 more for the rest. So we also have time assertions now. They use this new Fluent syntax, which is just a string. It basically just looks at the first 1, 2, or 3 letters. So you can say what kind of time span you want, like 1 min, 2 mins. You can even misspell it and see minutes, and it will still accept it. And so the idea behind this is you are creating a file or you're getting a report from some web API and you want to say, I put into the filter that the report shouldn't report anything that's older than 30 days. And then you want to have an easy way to check on every single item that you got back that it's newer than 30 days. So in here it says it should be after. So this is our hard case. And then you define what the time is. So this should be not older than 1 week ago. The syntax might get some used to. We also discussed with Frode how to change it to make it either more obvious or less obvious or more flexible. But I think this syntax is kind of nice and useful. So another assertion that's there, it should be faster than if you want to measure some speed. You don't have to wrap it yourself into stopwatch or into measure command and then compare it, painstakingly create a time span from either the correct syntax or from the time span from seconds. You just say, here's a script block or a time span, and it should be faster than 1 second. It runs, reports, and yes, go on, your question. Have you been talking with Bruce before? That's a possibility, yes. If a script block should be faster than the other script block, we can do it, but I don't really see how. Where would you even use that?
It's on the plus equals. From the
Okay. Use profiler. So those are Fluent assertions, the time assertions with the Fluent syntax. Do we have a demo for that? Yes, we do. So here I have a notepad and I'm checking if the creation time is less than 1 week ago. And it's not because I installed the system earlier. And so I get this array this error that says the provided date time to be after this, but it was before this. And it was exactly this thing. So that's why my notepad became alive. And then I have the same thing where we do start sleep. and it should be faster than 1 second, but it's not because start sleep waits for that 1 second plus a tiny bit, and so it doesn't pass my assertion. For some crazy reason, this fails on some CI server for a reason that I don't understand, but not your problem.
Can you make it fuzzy? Like it should be within 5 seconds, but not exactly 5 seconds.
Not right now, but you easily could. If you make a pull request and we manage it.
So how does it handle time zones and the date time, like it's unspecified or UTC, being like the different ones?
That's a good question.
Sorry, not time zones.
Okay, cool.
UTC or unspecified.
Right, so the previous question was if the time is fuzzy, if we can define here, should be faster than like 1 second plus minus few milliseconds. Right now, no, and I said make a pull request. Another question was how do we handle time zones? Right now, we just take the datetime object and we just compare it through the standard PowerShell operator. So if that handles it, we handle it. If it doesn't handle that, we don't handle that.
The datetime object actually contains the UTC object.
If we are doing it correctly inside of parsing of this 1 week, then probably would work. If no, another pull request in the making. This is getting better and better.
It's just very brave to do time handling.
I don't handle the time. I only compare it. And then what do we have? Yes, closing. So we never talked about negating assertions, and so now you embed the not into the name of the function, because it turns out not every assertion needs to be negatable, and it sometimes brings a lot of confusing behavior when people start adding not in front of assertions that are written with just the positive case in mind, like should have parameter. If you say should not have parameter, what exactly does it mean? Not have the parameter with this name, not have the parameter with this type when you follow it with all the other things. So not every assertion in this new set has not, such as should be greater than and should be less than equal, because they are complement. So that's one short note. Oh, God. Please.
A scenario for should not contain like a parameter would actually be useful for testing.
Okay, so the comment is that should not have parameter would be useful for testing restricted run spaces. I agree with you, yes. I totally know what you're talking about.
You have that's pretty good. What you have greater than, and the inverse of that's less than or equal to. So having a not greater than doesn't make as much sense.
That's what I'm trying to say, yes. Yeah, thank you for the comments. For all your pull requests that I can totally see being commented. So that's this. Then migration. When I wrote this talk, I thought we will be way further ahead, but then it took so much work to migrate the code into Pester, do the changes. I didn't end up having so much time, but no migration so far. Recently, we added a option that you can use after you migrate in the future, or if you attempt right now, and then you don't want to have the other old assertions being used anywhere, you can disable them by this. They will still be present as functions, but they will throw on the entry point for every single assertion. Also, all the should assertions that are there, like should invoke, should have parameter, and so on, will have an equivalent in the new library, so you can migrate to them fully. There probably will be a migration guide in the future once this matures a little bit, but that's your opportunity to kind of mold it and share your feedback and tell me where the inconsistent messages are and so on. So please go and file some issues. And with that, we are way past the Q&A because we put it in. But if there are any more questions, reach out to me or ask it here. I don't know if there's any session after this as well, so we can talk. Thank you very much.